This incident highlights a chain reaction of failures stemming from incorrect load stacking, where standing bulky items vertically creates an unstable center of gravity. Beyond this operator error, the lift's open platform design and lack of safety interlocks permitted operation despite the load extending beyond the cabin boundaries, creating dangerous shear points. The absence of collision sensors allowed the equipment to continue moving after the load snagged on a structural member, turning the cargo into a compressive column. This generated immense leverage and torque that exceeded the structural capacity of the cabin. When the components failed, the resulting sudden release of stored mechanical energy displaced the operator with significant force. This serves as a vital reminder that safety depends on both rigorous operational discipline and robust, fail-safe equipment. This incident was caused by a sudden structural failure or connection decoupling within the load-bearing system, resulting in the uncontrolled release of potential energy. Root causes included overloading beyond rated capacities, improper rigging at the center of gravity, and dynamic loading from abrupt crane movements. These factors, combined with equipment degradation, created significant hazards including uncontrolled load descent and crane instability. Such incidents underscore the extreme danger of personnel occupying the zone of danger beneath suspended loads. To prevent future occurrences, it is vital to mandate rigorous center of gravity calculations, regular certified rigging inspections, and smooth operational techniques. Furthermore, establishing clear exclusion zones and utilizing standardized signaling are essential to minimize risk. This event highlights the necessity of shifting from experience-based methods to a technical, safety-first culture in construction. This incident highlights significant behavioral and operational lapses, driven by overconfidence and a preference for showboating over established safety protocols. Attempting to force a structural partition without controlling the collapse is a serious deviation from professional standards and reveals a failure to conduct proper risk assessments or structural evaluations. Technically, the machine's operation was flawed. Track loaders have high centers of gravity, and applying excessive force to a wall creates dangerous instability when the structure suddenly fails. Positioning equipment too close to the work face and using loaders for heavy demolition further exacerbates risks. These hidden hazards, including the potential for total rollover, falling debris, and being pinned in confined spaces, demonstrate that safety depends on precise, controlled demolition, not reckless maneuvering. This incident illustrates the critical risks associated with operating truck-mounted loader cranes in high-traffic industrial environments. Key technical vulnerabilities include significant blind spots around the crane chassis and compromised situational awareness, as lifting operations often proceed without ensuring the load path is entirely clear. Furthermore, the lack of site segregation, such as absent floor markings or safety barriers, acts as a primary contributor to collisions. To mitigate these risks, facilities must enforce the clear load path rule, which strictly prohibits personnel or equipment from entering the active radius of a crane's boom. The role of a dedicated spotter is equally essential for monitoring blind spots and signaling emergency stops. Strict adherence to designated parking zones is vital. Ultimately, workplace safety relies on robust warning systems, site infrastructure, and the individual commitment to safety protocols. The primary cause of this incident was the forklift operator's failure to maintain situational awareness, exacerbated by excessive speed and restricted visibility. Simultaneously, the pedestrian was operating a pallet jack while walking backward, a high-risk maneuver that impaired their rearward awareness. This collision highlights a critical breakdown in warehouse communication, as no audible or visual warnings were utilized, and essential safety systems were either inactive or ignored. To prevent similar accidents, facilities must enforce strict pedestrian right-of-way protocols and prioritize the separation of traffic via designated walkways. Employees must minimize reverse travel and utilize spotters when necessary. Furthermore, mandatory, recurring safety training and the consistent use of warning devices are essential. Adherence to these measures is critical to ensuring a secure warehouse environment. Deep shaft construction involves high operational risks, primarily due to unpredictable environmental factors like sudden water intrusion. This incident demonstrates that inadequate environmental control, specifically the lack of robust drainage, sumps or flow control barriers, constitutes a critical safety failure. In restricted environments, rising water severely compromises egress systems, rendering rapid escape nearly impossible. Furthermore, working without continuous surface monitoring leaves personnel without early warning or immediate rescue support. To mitigate these hazards, teams must perform thorough risk assessments regarding groundwater and nearby utility integrity before work commences. Projects must implement active warning systems, provide specialized TP for wet environments, and maintain dedicated surface-level supervisors to monitor conditions and trigger emergency procedures instantly. Neglecting these protocols is a failure that threatens both worker safety and project integrity. Exiting an operator's cab without ensuring the equipment is in a static state is a severe safety violation. Key operational errors include parking brake failure, failure to properly secure the transmission, and leaving elevated loads unattended, which shifts the center of gravity and creates inherent instability. When equipment remains powered or hydraulic circuits stay active, the machine remains in a sensitive waiting state, where minor vibrations can trigger unintended movement. Once an operator leaves the seat, the ability to intervene via pedals or steering is lost, turning the machine into unconstrained mass subject to gravity. Operators must follow the secure shutdown, exit protocol, shift to park, engage the parking brake, lower all attachments and shut down the engine. Never rely solely on gear selection, and always use wheel chocks on inclines to prevent accidents. To prevent recurrence, businesses must implement rigorous safety standards to both engineering and administrative controls. Engineering measures include installing self-closing mechanisms like counterweighted hinges to ensure remeasure should automatically, and applying high contrast hazard tape around openings for clear visual alerts. Administratively, facilities should adopt a scan before you step protocol, training personnel to verify floor integrity constantly. Furthermore, a strict zero-exposure rule must be enforced, requiring that access points never be left unattended while open, regardless of how brief the absence. Regular safety audits are also essential to identify and mitigate infrastructure vulnerabilities before they pose risks. This incident is not merely an isolated mishap but a symptom of gaps in safety management, and shifting the focus from individual error toward proactive infrastructural safety is critical for ensuring long-term workplace wellness. High-pressure discharge incidents often stem from a failure to manage the physical interaction between personnel and equipment. Technologically, fluid flow at high velocity creates reaction forces that can easily overwhelm human balance, especially when operating on unstable, saturated terrain where traction is compromised. Human error frequently plays a role, particularly when operators underestimate the strike zone or fail to maintain a proactive stance. To mitigate these risks, organizations must move beyond relying on operator agility. Root cause analysis consistently highlights the need for better engineering controls, such as remote-operated systems and fixed nozzle mounts, which enforce physical separation. Furthermore, rigorous site assessments are mandatory to ensure ground stability before any work begins. Ultimately, industrial safety should be integrated into the system architecture. By anticipating potential equipment surges and establishing clear paths of egress, we create a resilient work environment that prioritizes engineering over human reaction time. The most significant technical breakdown in this incident was the failure to implement LOTO procedures. In any industrial setting, maintenance or clearing material jams on active machinery necessitates a zero-energy state. Lockout, which means de-energizing the machine and securing the power source with a personal lock, and tagout, which involves affixing clear warning signage. Interacting with pinch points while a machine is in an operational state is a critical violation of engineering safety. Industrial presses also possess significant operational inertia, meaning mechanisms continue to move due to stored kinetic energy even after a stop command. Familiarity with daily tasks often leads to the normalization of deviance, where workers bypass shutdown protocols. This represents a dangerous trade-off between productivity and personal safety.